welcome back. So we're looking at lesson 3 today, balanced moves. So more of dealing with equations and using, thinking about balancing our moves and making sure we're doing the same thing to both sides. All right, let's go ahead and jump right in. So matching equation moves. So obviously I can't give you the cards, but we're going to run through them together. Each of the cards 1 through 6 show 2 equations. Each of the cards A through E describe a move that turns one equation into another. Match each number card with a letter card. One of the cards will not have a match. For this card, write 2 equations showing the described move. So looking at our equations, so the first one we have here is 3x plus 7 equals 5x. And then it became 7 equals 2x. How did we go from this first equation to the second equation? Well, we subtracted 3x from both sides. Or another way to think of it is we added a negative 3x to both sides. Well, that goes with B right here. We add negative 3x to each side. All right, our next one here, we have 12x plus 3 equals 6. And we have 4x plus 1 equals 2. How'd we go from having 12 to having 4? We divided or multiplied each side by 1/3. So that one goes here. We just multiplied all of this by 1/3 to get to this here, and that's perfectly acceptable. These two equations result in the same answers in the end. All right, we have 10 minus 6x equals 4 plus 5x, and we have 7 minus 6x equals 1 plus 5x. What did we do here? How'd we go from 10 and 4 down to 7 and 1? Now, I will tell you this isn't something we often would do here because typically we want to combine our terms and work to get constants to one side, variables to the other, but this is something we could do. We added negative 3 to each side. So 10 minus 3 is 7, 4 minus 3 is 1. All right, on number 4, we have 5x divided by negative 3 equals 12 divided by 1. We end up with 5x equals negative 36. What did we do in this one? How did we get rid of the negative 3 in the denominator? Well, to undo division, we multiply. So we multiplied both sides by the negative 3. That would cancel out. 12 times negative 3 is negative 36. That goes right there. All right, and number 5, we have negative 3 times the quantity 4x minus 3 equals negative 15. And we ended up with 4x minus 3 equals 5. So how'd we go from having this negative 3 here to no longer having it? What'd we do? Well, we divided by negative 3 on both sides. Or let's see, they probably multiplied by fraction. So you can multiply by a fraction. It's the same thing as dividing. It's just, that's up to you how you want to think of it. And the one that we didn't have one for was C, add 3x to each side. So a possible set of equations would be 5 minus 3x equals 2x plus 8. And then we'd have 5 equals 5x plus 8. We added the 3x right here to both sides. So this is looking at keeping it balanced. What we do to one side of the equation, we have to do to the other side. We have to keep these equal. So equal is your key word for this lesson, equal. All right. So keeping equality, Noah and Lynn both solved the equation 14a equals 2 times the quantity a minus 3. Do you agree with either of them? Why? So let's take a look at what they did. So here we have 14a equals, we have the original equation in each of them. Then here, it looks like Noah distributed the 2 to both the a and the negative 3 to get 2a minus 6. So far, so good. Then we got down to 12a minus 6, so subtracted the 2a. That's good so far. So we have 12a equals negative 6. To get a by itself, we divide, so we end up with a negative 1/2. Noah's solution is good. So, good. Lynn, let's see what she did. So instead of distributing, Lynn divided right away. So she took the 14a and divided it by 2 to get 7, and divided all of this by 2 to get just the a minus 3. So then subtracted the a from the 7a to get 6a equals negative 3, divided, and this also works. So sometimes there's more than one way to take and solve a problem, especially when we have cases like this where there's the distributive property involved, because sometimes you can take and divide it out right away. Other times it works best to take and distribute it. It just depends sometimes on what your values are. So both are correct. All right. Elena is asked to solve 15 minus 10x equals 5 times the quantity x plus 9. What do you recommend she does to each side first? Now, in this one, there's 2 different ways that we can do this, just like in the last one. Elena could distribute the 5x to both, or distribute the 5 to both the x and the 9, or being as 15 and 10 are both divisible by 5, she can divide by 5. So 2 ways. Distribute 5, or divide both sides by 5. So there's 2 different ways, just like there were here. Now, number 3, Diego is asked to solve 3x minus 8 equals 4 times the quantity x plus 5. What do you recommend he does? Now, technically there are still 2 ways to take and do this. He can divide both sides by 4, but you're going to end up with a fraction. So most people typically don't like to see fractions in there, and so would rather distribute first and then end up with a fraction later on if necessary, rather than right away at the beginning. So still 2 ways, but distributing will be easier. No immediate fraction. So an attempt to avoid having fractions right off the get-go. So like I said, different ways to take and solve problems like these, but both work in the end no matter which one you choose to take and do. So it's all about your preference in these, because like I said, you can have fractions as long as you're comfortable with working with them. That's perfectly fine. The goal, though, is you have to keep both sides equal. So what you do to one side, you have to do to the other, except for distributing. That's the only thing that can happen on just one side, or combining like terms. That can happen on just one side without it having to go to the other side. Okay? All right. If you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.